My name is Prithvisha Nath and I am the TA for this course, Vibration of Continuous System. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 8 for this course. So let's start solving some questions. For the first question, we have to find the free vibration response of a rectangular membrane of sides A and B subject to the following initial conditions. Wx comma y comma 0 equals to W naught sine pi x by A sine pi y by B. For x greater than equals 0, less than equals A. Similarly, partial differential of W with respect to t equals 0 at x comma y comma 0. For x equals 0 to A and y from 0 to B. So we can write the general solution sine of m pi x by A sine n pi y by B into AMN cos omega mn t plus BMN sine omega mn t. Now, if Wx comma y comma 0 is denoted as this and partial derivative of W with respect to t is denoted as W dot naught x comma y suppose this is equation number 1, this one. This is for 0 to A and y from 0 to B. Now equation 1 becomes equation becomes W naught x comma y. The sign terms will remain. And the coefficient for the cos term will be there. So AMN. And from the second condition, what we get is omega mn bmn sine m pi x by a sine of n pi y by b. Now what can we write? Now we need to find out AMN and BMN. So we can write AMN as 4 by AB W naught x comma y sine m pi x a sine of n pi y b dx dy. Now in place of W naught we can substitute this expression. In place of W naught we can substitute this expression. So this becomes 4 by AB 0 to a omega naught sine pi x a pi x divided by a sine m pi x by a dx, and y is varying from 0 to b, so sine of sine of pi y by b sine of n pi y by b dy, and BMN can be written as 4 AB omega mn integration 0 to a x comma y sine m pi x A into sine n pi y b dx dy. Now y dot x y dot x comma y is 0. So Bmn is 0 for the given data. Now we need to solve for Amn. We already found out Bmn to be 0. Now we can use a relation to solve for Amn. We can use this relationship. We can use this formula using the relation sin alpha t sin beta t dt equals to half sin alpha minus beta divided by alpha minus beta t minus sin alpha plus beta divided by alpha plus beta. Here alpha not equals beta. So for solving Amn we can use this relation. Now let me number the equations. Suppose this is the second equation. This one the third and this one is the fourth. Now this one, let this one be fifth and this one be sixth. We can use the above relation to simplify equation 5. So what was AMN? I will write down AMN. I will write down the equation in terms of this relation. So what will AMN become? We can write this as four W naught divided by AB into half of sine m minus 1 pi x by A divided by m minus 1 pi by A. Similarly, for the second part of the equation, we can write this as sine m plus 1 pi x by A divided by m plus 1 pi by A. This will vary from 0 to A. Now we have another term for y which varies from 0 to b. This was for x, now we will write for y. So we can write this as into half sine of n minus 1 pi y by b divided by n minus 1 pi by b, and the next term is minus of sine n plus 1 pi y by b whole divided by n plus 1 pi by b, and this varies from 0 to b. Now what can we say from this equation? AMN, we can say that AMN is 0 for values greater than m for m greater than 1. Or n greater than 1. So we can write AMN equals 0 for m greater than 1 and or n greater than 1. Now what happens for m equals 1? for m equals 1 and n equals 1, equation 5 can be simplified as, now since m equals 1 and n equals 1, I can write amn as a11. Now how can we simplify amn? In place of m, I'll substitute 1. In place of n, I'll substitute 1. So this becomes w naught in 4w naught a by divided by ab sine square pi x by a dx. Similarly for the y integration in terms of y, sine square pi y b dy is left. So this I can simplify as a11 becomes 4 w naught ab 0 to a sine square pi x by a dx, and for y 0 to b sine square pi y by b dy. Now let's see what we get by simplifying this, by solving this. How can I write sine square pi x by a? It can be written as 1 minus cos of 2 pi x by a divided by 2 from 0 to a dx, again for y 0 to b 1 minus cos 2 pi y by b divided by 2 into dy. Now this 2 gets cancelled with 4, so a11 w naught by ab 0 to a 1 minus cos 2 pi x by a one minus cos 2 pi y by b dy. So if I integrate this, I'll get this as x minus sine 2 pi x by a divided by 2 pi by a from 0 to a into y minus sine 2 pi y by b divided by 2 pi by b. This varies from 0 to b. Now if I substitute, what will I get? W naught AB A minus sine of 2 pi A by A divided by 2 pi A B minus sine 2 pi B by B divided by 2 pi B. Now what do we get? So sine 2 pi is 0, therefore A is left from the first term and B is left from the second term. So this gets cancelled. Only W naught is left. So the final solution can be written as I got AMN as W naught. So from this equation what can be written? BMN is 0, AMN is W naught. So the final expression will become W naught sine pi x by A sine pi y by B cos omega 1 t, and AMN is W naught. So the final expression becomes sine pi x by A sine pi y by B cos of omega 1 t. So this is the final expression for W. Now moving on to the next question. Find the free vibration response of a rectangular membrane of sides A and B subjected to the following initial conditions. Now W is 0 at time t equals 0, and partial derivative of W with respect to time at time 0 is given. Sin pi x by A sin 2 pi y by B. For x zero to A and y 0 to B. Now how can we do this problem? Now again we can write the general solution. W x comma y comma t sin of m pi x by A sin of n pi y by B into AMN cos omega mn t plus BMN sin of omega mn t. Now if wx comma y comma 0 equals to w naught x comma y and this is w dot x comma y for x varying from 0 to a and y varying from 0 to b. So what we will get? T is 0. For the initial condition t is 0. So what we will get is sine of m pi x by a sine of n pi y by b into amn will be equal to w naught x comma y. Similarly, for the from the second condition, what we will get is omega mn bmn sine of m pi x by a sine of n pi y by b w naught with a dot x comma y. Now how can I write amn as? amn is given as 4 divided by ab 0 to a w naught x comma y sine of m pi x by a into sine of n pi y by b dx dy. Now we know that w naught is 0 from the given data. Therefore, amn is 0. From the given data. Now I need to calculate bmn. How can I write this as 4 divided by ab omega mn 0 to a 0 to b x comma y sine of m pi x divided by a sine of n pi y by b dx dy. Now I'll substitute. This can be written as 0 to a sine of m pi x by a into sine of pi x by a dx, and for y terms it is sine n pi y by b into sine of 2 pi y by b dy. Now again we will use the similar relation which we used for the first problem. So using the relation sine alpha t into sine beta t equals to half sine alpha minus beta t divided by alpha minus beta minus sine of alpha plus beta t divided by alpha plus beta. Now if we apply this relation to BMN, what can I write this as? Therefore BMN can be written as 4 W naught dot divided by A B omega Mn for the first integral. I can write this as sine of m pi m minus 1 pi x divided by a and whole divided by my m minus 1 pi a minus of sine of m plus 1 pi x divided by a whole divided by m plus 1 pi divided by a. Now for the second term, that is for this y, for the y terms, again I can write this as into half sine of n minus 2 pi y by b divided by n minus 2 pi by b minus sine of n plus 2 pi y by b n plus 2 pi by b. Now the first term will vary first for the x terms. This will vary from 0 to a, and this will vary from 0 to b. Now this 2 and this 2 gets cancelled with 4. So what can I write? This is equals to 0 for m not equals 1 and n not equals 2. Therefore, I can find B12. B12 can be written as for W naught dot AB omega mn sine square pi x a dx, and this is from 0 to b, sine square 2 pi y b dy. Now what will I get if I integrate this? Like the earlier problem again, we can write this. Zero to a 1 minus cos 2 pi x divided by 2. This is for the x term, and for the y term, how can we write this? One minus cos 4 pi y by b divided by 2 dy. Now again I can cancel this 2 with this 4. So what can I write next? W naught dot AB omega n, this will become x minus sine 2 pi x by a divided by 2 pi by a. This will vary from 0 to a. For the y term it will become y minus sine of 4 pi y by b divided by 4 pi b from 0 to b. Now after substituting the values, what will I get? A minus sine 2 pi a by a. Now if I substitute 0, it is this term will be 0. In place of x, if I substitute 0, so I'm not writing that, divided by 2 pi a, 2 pi by a. Similarly for the y term, it will be b minus sine 4 pi b by b divided by 4 pi divided by b. So what can I write? Only a and b are left. Therefore, I can cancel this 2 omega mn. So in place of mn, I can write 1, 2. Therefore, so what is the final expression for W? In place of Bmn, I will write sine pi x by a sine 2 pi y by b into sine of omega 1 to t. This is the final expression for W. Now moving on to the third problem. Find the free vibration solution find the free vibration solution and the natural frequencies of a rectangular membrane that is clamped along all the sides the membrane has dimensions A and B along the X and Y directions respectively. So here what do we need to do? We need to find the free vibration solution and the natural frequencies for the rectangular membrane that is clamped along all its edges, and the dimensions are A and B. So what can we do? We can write W x comma y comma t as capital X, capital Y, capital T. So this can be written as C1 cos alpha x plus C2 sine alpha x into C3 cos beta y plus C4 sine beta y into A cos omega t plus B sin omega t. Now what are the boundary conditions? Boundary conditions. W0 comma y comma t and WA comma y comma t is 0 for y which varies from 0 to b and t greater equals 0. Similarly, W x comma 0 comma t equals W x comma b comma t equals 0 for x0 to a and time greater equals 0. Now what can I say from this given conditions? I can say that capital X at 0 and capital X at A is 0. Similarly, capital Y at 0, capital Y B equals 0. So, what can we say from this? C1 is 0 as and C3 is 0. Similarly, therefore, again, what can we say? Sine, we also can say that sine alpha A is 0 and sine beta B is 0. Therefore, what can we say from this condition? We can say that sine alpha A equals to sine of m pi. Therefore, what can I write? Alpha m as m pi by A Therefore, m can take values 1, 2, and similarly for sine beta b equals to sine, we can write this as n pi. Therefore, this implies beta n equals to n pi b. N can also take value 1, 2. Therefore, I can write omega mn square equals c square pi square m square by a square plus n square plus by b square. So how can I write the displacement solution? The displacement solution is sine of m pi x by a sine of n pi y by b into amn cos of omega mn t plus bmn sine of omega mn t. Therefore, the general solution is this is the general solution. Now I will substitute Wmn. sine of m pi x by a sine of m pi y by b AMN cos of omega mn t plus BMN sin of omega mn t. So this is the general solution. So for the first question, what did we find out? We had to find out the free vibration response of a rectangular membrane subjected to the following conditions. Now we wrote down the general solution for a rectangular membrane. Now for time t equals 0, we got W naught as this. Only the coefficient of cos term was remaining. And for W naught dot, this was the equation at time t equals 0. And we know AMN can be expressed in this manner: 4 divided by AB, double integration over W naught xy sine m pi x by a into sine n pi y by b dx dy. Now in place of W naught xy, we substitute the given condition. Now for the x term, now we have separated the x and the y terms and perform the integration for the x and y terms respectively. We need to perform integration respectively for x and y terms. Similarly for BMN, this is the expression: 4 divided by AB omega mn, double integration over this entire term, and we know that from the given data we know that W naught dot is 0. So BMN becomes 0. Now for finding out AMN, we simply use this relation. Which is given in this manner. Now we apply this relation to calculate AMN. After substituting, this is the form of the equation. We can say that AMN is 0 for m greater than 1 and or n greater than 1. For m and n equals 1, we can simplify this equation number 5, this equation, as this x terms become sine squared pi x by a and the y term becomes sine squared pi y by b. Therefore, we perform the integration for a11. Now we write sine square terms in terms of cos. We use that relation 1 minus cos 2 theta. Then after performing the integration, we substitute the limits and finally get a11 as w naught. So the general solution becomes like this. Now for the second question, we are given w is 0 whereas partial derivative is non-zero for the same rectangular membrane. So this is my general solution. Now for t equals 0, only AMN is left. That is the coefficient of cos omega and mn t, and sin m pi x by a and sin n pi y by b is left. So w naught becomes AMN sin m pi x by a into sin n pi y by b. Similarly, partial derivative of w with respect to t becomes like this. Now we know AMN can be written as 4 divided by AB, double integral over this expression. So we know that W naught is 0. So AMN becomes 0. Now we have to calculate BMN. BMN is given by the expression 4 divided by AB into omega mn and double integral over this term. So I substitute the value for W dot, which is given in the question. Now I integrate the x terms and the y terms separately. Again I use this relation which I used for the earlier question. Now what I do is I apply this relation to solve this integral. Now we see that we can say BMN is 0 for m not equals 1 and n not equals 2. Therefore, I calculate B12. So after simplifying like the previous problem, we get B12 as omega dot naught, sorry, W dot naught divided by omega 2, 1 2. So my W expression for W becomes this. This is W. For the third question, what did we do? We had to find out the free vibration solution and natural frequencies for a rectangular membrane that is clamped along all the sides. And the membrane has dimensions A and B along x and y directions respectively. So I write W as this. Now these are the boundary conditions for this problem. For x and all for y along y at any time t is greater than equals 0, and for x equals a and any y and t any y means y from 0 to b, and time greater than equals 0, it is w is 0. Similarly for x comma 0 comma t and w x comma b comma t, it is 0. So we can say that capital X at 0 is 0 and capital X at A is also 0. So what can I say? I can say that C1 is 0, and from Y, and we also know that Y, capital Y at 0 and capital Y at B is also 0. So I can say that C3 is 0 and similarly sine alpha A is also 0 and sine beta B is also 0. So alpha turns out to be m pi by A and beta n turns out to be n pi by B. Therefore, the natural frequency becomes like this. And finally, the general solution turns out to be this. So these are the problems that we solved for this week. We will stop here.